everybody, it's Mr. Define once again. Welcome back. This video will be about the two examples I mentioned in my previous video regarding the law of cosines. In my last video, I derived the law of cosines, and in this video, I want to show you how it actually applies. So here we go. In example 1, the question is, what is the length of QR? So my focus is to try to find that length right there. Now, I noticed that I have an angle right here. I also have a side length here and a side length right there. Now, this wouldn't be enough to use the law of sines because I would end up having two unknowns, and that wouldn't really help me out too much. So the law of cosines is nice because it increases your flexibility for being able to get more of what you need from these triangles. So here we go. I'm going to go ahead and call this my side S. This will be my side R. This will be my side Q. And even though they're not A, B, and C, the principles still apply. So my focus angle is angle S, and my focus side is the side opposite of that angle, which is side S. So it's going to go like this. This is what I need. And what I therefore should have information about are sides Q and sides R. That's going to be minus 2QR, and then cosine of my focus angle, which is angle S. Okay, notice once again, there's a correspondence between the side that I either need or the angle that I need. Okay, and then everything else between, all the variables in between those two yellow highlighted marks, you should already have information for it, so you can just drop them right in. So what I can do is go ahead and continue here. So I know that S is my unknown. Q, however, is 8, so this becomes 8 squared. R is 10, so this is 10 squared. This is minus 2 times 8 times 10 cosine, and my focus angle is known to me. That's 48 degrees. So there it is. So pushing on, I have 64 plus 100, and if I multiply all three of these numbers together, I would get negative 160. Now, the cosine of 48, that comes out to 0.6691. So it's 0.6691. When you're doing these kinds of questions, it's a good idea to use about 4 or 5 decimal numbers. And then at the very end, if you want to round it, you can round it to the nearest tenth. But in the intermediate process, having more digits after the decimal increases your accuracy. So when you do finally round it to the nearest tenth at the very end, your answer is still pretty close to what it should actually be. So I have S squared is equal to, this is 164 minus, and if I multiply that times 160, I get 107.0609. 0609. Okay, that's rounded. And then I go ahead and do my math again. So 164 minus 107.0609 comes out to be the following. So I get 56.9391. And obviously you'll need a calculator for this, but by doing the square root of both sides, here and there, you can disregard the negative part of that answer and just keep the positive. And I'm going to increase my space here, so excuse me 1 second. There we go. My S comes out to the following. It comes out to 7.5. Okay, that's rounded to the 10th. So S is 7.5, which means QR is 7.5. And with that, this example is completed. Okay, let's go on to example 2. In example 2, the question is, what is the value of the angle D. So this time we're not looking for the length of a side, because if you notice, I have all three sides here, but I don't have a single angle known to me inside the triangle. So my task is to figure out the length, or excuse me, the measurement of one of these angles at D. Once again, the law of sines would be no good, because to use the law of sines, you need to know your angles. So this is definitely a job for the law of cosines. So here we go. Once again, I'm going to label my sides as E being that, F being the 19, and little d, I'll put it here, little d being the 21. All right, so I will set it up according to what I have and what I need. So I need this angle, but what I have is a side opposite of that angle. So my d's are my focus for the law of cosines, and so it will go something like this. It'll be d squared is equal to, now I have d this time, okay? In the last example, I needed to get the side. I have the side this time. What I don't have is the angle, so just bear that in mind as we go through this. The other parts, f and e, are known to me, so they will be e squared plus f squared minus 2 ef cosine, and then my focus angle, which is d. Okay, once again, notice that these correspond with each other, and they always will. So one of these will be my unknown, and in this case it's my angle, which I don't know. So I'm trying to figure out, what is that? So here we go. My d becomes the 21, so it's 21 squared. My e is 11 squared. My f is 19 squared. This is minus 2 times 11 times 19, and this is cosine of my focus angle, which I don't know again. So 21 squared is 441. This is 121. And 19 squared is 361. Okay, and if I multiply these three digits together, 22 times 19 gives me 418 cosine d. All right, moving along, combining these two together, I'll shrink it down. I get 441 is equal to, that will be 482 minus 418 cosine d. Now, this is just like solving a regular algebra 1a equation, where I have to isolate what I'm trying to solve for. What I'm trying to solve for this time is d again, okay? This d is connected to cosine, so I'm trying to isolate cosine d. And at the very end, just d by itself. So for now, I need to move this 482 to the left side, and I'll do that by using the subtraction property of equality. So when I do that, what I get is 441 minus 42, and that's negative 41. Okay, so this is negative 41 is equal to negative 418 cosine of d. If I divide both sides by negative 418, I'll just go ahead and show you that step here. So if I divide everything by negative 418, what I then get on the left side is positive 0.0981. On the right side, I just have cosine of d. Now, to get the value of the measurement of angle d, what I have to do is use the inverse trigonometry feature of cosine. So inverse trig function of cosine, or inverse cosine, and that would be the following. So the measurement of angle d would be the inverse cosine of 0.0981, and that would be 0.0981. Just doing the inverse cosine here, 84.4. So the measurement of my angle d is equal to 84.4 degrees. Make sure that when you're using your calculator to do this, that it's in degrees mode instead of radians mode, because you will get a different answer. And that's the end. Now, if I wanted to, I could figure out the values of angles E and F, but in this case, I don't need to do that. Okay, and remember, the triangle angle sum theorem says that if you have two angles known to you in a triangle, the third can be easily gotten by just doing the sum, subtracting from 180. So you wouldn't need to use a law of cosines to get all three angles inside. Once you know two, you're good to go. So I hope this video helped you out. Please stop by, leave a comment, and as always, thanks for watching. Bye.